Good morning, everyone. This is going to be a video for Chapter 1, Variables. I'm going to go a bit faster. There are a lot of good Python tutorials online, and there's so much to cover. But I do just want to give you the basics that you'll need for this AlgoLearn-based tutorial series. So let's get started. So you should have Visual Studio Code installed. If you just Google Visual Studio Code, go to the website. If you're on Windows, Mac, just download the appropriate one. And when you get here, you'll see an icon once you have this open with three boxes shaped kind of like an L and an offset square here, an offset box as well. Go in here and download Python IntelliSense, and I'm going to spell that out for you here. I'm going to create a new file. There's this paper with a plus sign, and then you can name your file. I'm just going to call it variables dot py. When you're coding in Python, always add .py suffix at the end of your file name. So the name of the extension is going to be Python IntelliSense. Okay, and what this will do is when you're coding, for example, if I have my variable equals 1, if you highlight, if you hover over my variable, you'll see it defines the type. It'll give you details here. The name of the variable, and it states here that it's just a single value. Conversely, if I did 1, 2, and I made it a tuple, which we'll go over later, you highlight over it, still a variable, it's still called my variable, but here you'll see it takes two values, and it's called a tuple. Okay, two values and a tuple, which we'll go over later. So make sure you get Python IntelliSense and the extensions down here, and download that. It's very helpful. It color codes things. It's super helpful. Do not skip that step. So with variables, there's several types. There's integers, strings, Booleans, more complex variable types like dictionaries and lists, and then tuples, which we'll go over last. Integers are pretty straightforward. We're also going to add floats here. Integers are pretty straightforward. So I'll say my int variable is equal to 1. And you can also, before I go into the integers, so when you create a variable name, it cannot start with a number. It cannot have spaces. And what else? There's one more you can't do. It's not coming off the top of my head at the moment. Dun, 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 dun. Oh, special characters, like that. You can't make combinations of any of these three. If you want to have a sort of space, you use this underscore character between words. Okay. And it doesn't have to be all lowercase. You can, if you wanted to, it's not typical, but you can do my int all capitals variable. Whatever you're most comfortable with. So let's have this variable, my int variable 1, and this is just simply an integer. You could do, let's create a second my int variable, or let's call it my second int variable. It's equal to 2. There's several arithmetic operators you can use. So I can do sum of my variables, just create a new variable, is equal to my int variable plus my second int variable. Excuse me, and we can print. This is a function that basically logs a result of your choice, or any variable of your choice, down here in the terminal. And let's print, so I'll just copy and paste this within the parentheses. All functions start with the name of the function, and then these open and shut parentheses with the thing you want to print within them. And we have another chapter for functions coming up. So don't worry too much about this. This is a very basic function that I think would be helpful to start off here. Anyway, so let's print the result of my int variable plus, just a plus sign. Oh, if I can highlight it. My second int variable. So let's run this. To run, you can hit Control F5. My F5 doesn't work on my computer. So I'm just going to hit run at the top here and run without debugging. Okay, and then this might pop up here. If you don't see Python debugger, it means you might need an extension. I mean, I just use this always. You could technically go in here and find an extension so that this never pops up again. But I just keep it with Python debugger. So the output is 3, obviously 2 plus 1. There's other arithmetic operators you can use, like modulus, which is, you won't really use it often. But let's say modulus or modulo of my variables is equal to my ints. Let's change this to 7 or 8 and change this to 3. Or let's do 5 actually. So my int variable is equal to 5. My second int variable is equal to 8. It's going to print some of my variables. We'll keep that there. And we're going to say my second int variable, so the second variable is in the front this time, modulo, which is a percent symbol, my int variable. And let's print the modulo, and you'll see this pops up, the variable here. Instead of typing the whole thing out, you can click or just hit enter, and it'll just pop up here, which is super convenient. And that's Python IntelliSense. So now let's run again. And we're going to get some of my variables first, and then modulo of my variables. Some of my variables is now 13, because I changed these numbers, 8 plus 5. And modulo is 3. If you're not familiar with modulos, basically it just takes a number, say 8, and it tries to divide it by 3. So 3, and then 3 plus 3 is 6, and then 3 plus 3 is 9. So we went over 8. So it's going to look at the previous I am so sorry, we're using 5. So let's say 5 plus 5 is 10. So we already went over, so it's going to go back and take the difference between these two. If this was 13, or let's say 14, it would do 5 plus 5, which is 10, plus 5, 15, we went over. Let's go back, 5, 10, and the difference is 4. 10 and 14, the difference is 4. So let's try that here, just to confirm. And we'll run this again. And we're going to get 4. You can also divide. There's two types of divisions. There's floating point and just general floor division. So let's do floor divisions first. So my second int variable, or excuse me, floor division is equal to my second int variable, single forward slash for division, my int variable. And again, don't use a space, use a underscore symbol. And let's print floor division. And we'll run this. And I don't think we need these anymore, so I'll comment them out. You can use a hashtag symbol to leave comments in your code or remove lines you don't need at the moment. So that might be useful in the future. So you'll see with floor division, you get, this is actually floating point division. You get a decimal. And then with floor division, so let's rename this floating point division. With floor division, you use 2 forward slash symbols, my int variable, print floor division. Let's correct this so we don't get an error. And you'll see the difference here. One has a decimal and one does not. So this just rounds to the nearest whole number. What else can you do? You can multiply. So let's comment these out. And let's bring our number variables down here. I can divide them twice. I can define the variables a second time here. Just remember that if I had this as 3 and 1, they're not going to be 3 and 1 anymore by the time the code gets down here. It reads from top to bottom. So down here, we have it as 5 for my int variable and 14 for my second int variable. So they will no longer be 3 and 1 since they're the same name here, the names of the variables. And we'll confirm that here when we run a test. So let's say we wanted to do, there's two types, general multiplication and then exponentiation. Use the same symbol just once or twice, similar to floating point division and floor division. So you can do multiplication by, so let's call it multiplied variable is equal to my int variable times my second int variable. And I believe this is 70. So let's print multiplied variable and run that, and we should get 70. Perfect. And then you have exponentiation. So let's do exponentiated variable. And again, you can call these whatever you want, the names of the variables, but I'm just using whatever whatever fits best. So asterisk, asterisk, my second int variable, and this will give you, for example, let's say this was 2 and this was 2. So this is the equivalent of saying 2 squared, like this. And let's run this here. Oh, should print it. Exponentiated variable. And this is probably a bad example. Let's use 2 and 6 because these will output the same thing. 2 times 2 and 2 squared. Okay, so 2 times 6 is 12. That's his first print statement. And then 2 raised to the 6 is 64. So let's go over floats. So floats is basically this. I don't think we need to go over them, but just know that when you have a decimal, you can print types. So I'll print this now. Let's keep or we'll just use the floor division and the floating point division print statements again. So when we print these, we get a float and an integer. And let's change these to 3 and 2. So we don't have 0. Oh, what am I doing here? Second by, okay, let's do 4 and 3. Second integer greater than the first, so we don't get a 0. So if you see here, this is the floating point, because it is a decimal, and this is a integer. This is an integer. And how can you confirm that? Let's print the type, and type is a class, and we're going to create an object, which we'll go over in another chapter. But basically, we're going to put this variable for the floats, and if you highlight, it says float. And you're going to print floor division as well. I'm going to copy and paste here and put floor division right here. And you'll see that we get the floating point again, the integer, and then the class, the type, which is float and int. Okay, so now we've confirmed. And we're going to delete all this and move on to strings. So a string is anything, so my string variable, let's call it 1, this is a sentence. Okay, it's a word, characters, or sentence surrounded by double quotes. You can also use single quotes. So what's the difference? What's the difference between these two? Honestly, I'm not sure if there is a difference. You could use either or. The only thing I can think of is, for example, my string variable 3, and let's say um, an f string. So what is an f string? An f string is a type of string where you can include variables into the string. So I can say here, the sentence I am printing is, and then curly brackets, and then I can just copy and paste this variable here, and it will print the variable. And then let's say, I mean, honestly, that doesn't explain why I would use double quotes or single quotes. A better example would be if you had an apostrophe in your sentence like this. But it's good we went over f strings anyways. If I did not use a single apostrophe here, let's say, or maybe this would be a better example like this. Let's say I wanted to use an apostrophe here. It's going to end the f string early. It's going to terminate it. And now we have a bunch of errors because it thinks that the f string is from starting apostrophe to the next apostrophe scene. So that's not what I want. So this would solve the problem. That's obviously not correct using a double quote. So we're going to do it this way. And now we know how to use f strings. And when we print this, you'll see that it's going to print the sentence I'm choosing is, this is a sentence. So let's confirm that here. We'll run without debugging. I printed the wrong variable. I swear I did not lie to you. Let's go here. Perfect. The sentence I'm choosing is, this is a sentence. With strings, you can also use arithmetic operators. You can do my string variable 1, and instead of typing the whole thing out, let's just select it. Or actually, let's call it my concatenated string variable. And concatenated just means combined, strings combined. So we'll say, let's change this. And this is another sentence. And you'll notice that there's a little glitch here, which I'll show you how to fix. So let's do my string variable 1 plus my string variable 2. So this is a addition arithmetic operation. And if I run this after printing it, you'll see that I get this is a sentence and this is another sentence. And I'll remove this for now. So this is a sentence and this is another sentence. But we have an issue here. We would like a space between these two sentences. So there's two ways to do this. You could either add a space here manually, okay, which might cause issues in the future if the order of these sentences might change. So what you could do is instead of adding the space in there, you can just add another string in the middle, which is a space character here. So a space character is still technically a character and is considered a string. This could even be empty, and it would still print as if, well, it'll be blank, there won't be a space, but it'll still be, this is still valid, an empty string. In fact, that's how you initiate some variables in the future, which we'll go over potentially. So let's print this, and you'll see this works. Space is now here, and you could do it the other way as well. We'll just showcase that really quickly. But again, this isn't really recommended because, again, these can be out of order. Okay. And you can also multiply them with an integer. So let's say my string variable times 3. And we'll print my multiplied string. and you'll have, this is a sentence with a space times 2. Oh, excuse me, 3. You could technically raise it. I don't think you'll ever do that. Um, and then you can also, I believe you can subtract. Let's try it. I don't think I've tried subtracting directly like this. No, you can't. So basically just plus and multiplication, exponentiation. Let's actually confirm. I've never tried it. Yeah. You cannot use exponentiation. You cannot use subtraction. You can concatenate, and you cannot concatenate two different types. It just won't work. And you'll see the error here. String can only concatenate string, not int to string. So you can only do two strings, not an integer and a string. And I said this video would be short, but it looks like we're going over this pretty much in depth. Let's move on to Booleans. We won't really have this. I mean, we might use it later, but let me go over it. So Boolean is basically just either true or false. So my true Boolean is equal to true with a capital T. My false Boolean is equal to false. And you're like, when would I ever use this? I'm never going to use this. Let's do, excuse me, we won't go over for loops just yet. But let's say for I in range of 10, print I. And this is a for loop. And you'll see what it does right now. It starts from 0 and goes all the way up to 10 values, which would be 9, which is tricky to understand. We always start from 0 unless you specify otherwise. But if you're doing this, you're now going to stop at 9 still, so you would need to go to 11. And I know this is confusing to hear at first, but now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how would we use a Boolean here? Well, we can use an if statement, which is a bit too early to go over, but we might as well learn it now. If I is equal to, let's say, 7, we're going to break. And then we're going to print I after the break. And I'll explain this in detail afterwards. And we're going to work up to the Boolean usage. So as you can see, it starts from 1, because that's the starting point. Range takes 2 inputs, and you can hover over it to see these. Class range, and this is a function, or excuse me, a class. Start is a number. Stop is a number. Okay, and these are indexes. So I start here at 1, I go to 11, but I don't count 11. Okay, it's tricky. This is just the way it is. Okay, I print I, so it prints I, and then it checks if it's 7. And when you're comparing two things, you use two equal signs, as opposed to when you're setting the value of something, you use one equal sign. Okay, so when you're comparing, checking if something is something else, you use the double equal sign. Okay, so you're just trying to see if this is true. And I'll print I equals 7. So this is a condition. So you could see what that is. And I'm just giving you more and more as I go. So 1, 2, 3, 4, 5, 6, 7. And at this point, it says, hey, this is 7. And if you print I equals 7, it gives you true, because the expression I is equal to 7 is true. Okay? And then another way, and then at the end here, we print I again, which is still 7. And the for I in range loop, when this evaluates to true, it breaks, so it stops. It doesn't proceed to go to 10, which we indicate with the stop index of 11. Another usage, while true. And then we'll have to highlight all of this and press tab to move it over. Because whenever we define something like a function or something that's going to be a starting point, we have to indent. So things that occur on the same line like these, print I if I equals 7, these are things that are executing within this loop. Okay, and you'll see here in a second. So while true, and this is going to get a little more complex. Let's say stop after x iterations, and let's say 3, or let's say 2. And for I in range print I also want to do stop after x iterations plus equals 1. So what this does, plus equals, just increments stop after x iterations. And I'm sorry, I'm going to change this to 0 so that I can show you the usage of this. So when it goes through the for I in range loop, it's going to print I, and then it's going to increment stop after x iterations by 1. So after this one runs once and breaks, my stop after x iterations will be 1. Okay. So the while true loop, when this breaks, it's going to go back up to the top and it's going to execute this again. And if I ran this right now, it would just go infinitely, forever. It would just never stop. But with the stop after x iterations, and I'm adding 1, I can add another check here. So let's say before I print I want to make sure if stop after x iterations is equal to 2, I'm going to set, or actually, I'm going to give you something else. Continuing, let's create a variable called continuing and set it equal to false. And if stop after x iterations is equal to 2, we're going to set continuing to false. So continuing, my goodness, falling apart here. Continuing is going to equal to false. And this should actually initially be true. So this is going to be true at first. And then we're going to say while continuing is equal to true. So you see, this is getting very complex. And I kind of want to challenge you. I want you to kind of get the hang of this. So let's kind of go over this, and we'll remove this for now. So we only have something simple to look at. And I'll zoom in a bit. We define stop after x iterations equal to 0. We define continuing equal to true. While continuing is equal to true, execute a for loop in I and define I in the range of 1 to 11, which is the numbers 1 to 10. Starting point, ending point does not count. So this is going to go on forever unless stop after x iterations is equal to 2. If it is, we're going to set continuing to false. And we're going to break here. So if continuing is equal to false, it's going to break out of the for loop here. And this is going to execute again. It's going to check if continuing is equal to true. It won't be because we just set it to false after 2 iterations. So this won't execute anymore. And we'll print here completed, a string. Okay. Inversely, you can set completed message equal to completed. And you could put completed in here. Completed message. If it's not equal to 2, we're going to print I, which will be a number between 1 and 10, and stop after x iterations, which is initially set to 0, will be incremented by 1. If we didn't increment it by 1, stop after x iterations would never be 2. It'll always be 0. Control Z to bring this back, Control Z. And if I is equal to 7, we're going to print I is equal to 7, which is true. This is an expression, a condition you're checking. And if that's true, up here, if this is true, we're going to break after we print this expression, this condition. Okay, so now let's run this. I hope that wasn't too much for you. And see the output here. Let's clear. I'm not sure why it didn't run. Might have to take a look at that. Okay. So let's see what happened here. Okay. So it went through here, checked if it was 2. It wasn't. It printed I. Stop after x iterations was incremented by 1. So it printed I, and then stop after x iterations was incremented by 1. I was obviously not 7, so it didn't print the value of the expression, and it didn't break. So it proceeded. For I in range 1 to 11. This is the second time. I is now 2. If stop after x iterations is equal to 2, which it's not, it's still 1. Continuing equals false, break. This doesn't happen yet, because this is still only 1, since we started with 0. Okay, after 2, checks if I is equal to 7. It does not equal 7. Okay, so now we go back to the beginning. For I in range 1 to 11. I is now 3. If stop after x iterations is equal to 2, we added 1 last time. We added it a second time previously after it printed 2. So this is true. Continuing is equal to false. We break out of the for loop, meaning we go back to this loop, and it checks if continuing is equal to true. It's no longer true. So this stops. We go down here, it prints the completed message. Okay. That might have been a bit much. Let's Control Z. Next up is Dictionaries. I believe Dictionaries is going to be Chapter 2. I'm going to continue, but I'll chop this video. I'll cut this video and clip it and put it into Chapter 2. Okay, so Chapter 2, Dictionaries. So dictionaries are kind of a difficult concept to grasp at first, but it uses something called key notation primarily. So what is key notation? Well, let's go over what a dictionary is first. And I always spell dictionary wrong. I don't know if it has that I in there. So my dictionary is equal to these curly brackets. So we can print the type of my dictionary, or we can just hover over it, and it says it's a dictionary. Type dict. And if we run this, we're going to get the output of the print statement, and it's dict. So this dictionary is not just curly brackets. You can include things within it. You can have a number, which is going to be a key, and then you can have a value. Okay? Or you can have a name key, and it could be string here. Or another example is you can have a age key, which is a string. if you'd like it to be. Well, if you're using characters, it has to be. And let's say 20, let's say 30. And let's print my dictionary. And it's going to come out looking exactly as it looks now. So what is key notation? Key notation is picking a key, which is the prefix to the colon. So key is first, value is second. Key is first, value is second. Key is first, value is second. So key notation is accessing the key. So if I do, and I'm actually going to give you another one here so that it's not in order, but you can still see, because this is going to conflict the next one, lists. And actually, we should have went over lists first, but lists are going to be way easier after learning dictionaries anyways. So let's get the key too. So we print my dictionary, and we say here, within these square brackets, which key we want. So we want the key that is equal to 2, which is this one. And when we print that key, the value is going to be 2. So we're printing the value to the key 2 in the variable my dictionary. So my dictionary has a key called 2, which we're accessing here using key notation. Okay? And then when we print this, we get the value of the key, which is 2 here. So let's say inversely or conversely, we wanted to print the key name. We wanted to print the value of the key name. So we want to print John. John is the value, name is the key. So instead of 2, we'll put name in here. And we'll run this. And we'll get John, which is the value to the key name. If you used lowercase n, this would not work. It'll say key error, name is not in there. Okay, so this is case sensitive if you're using strings. They have to be exact. And we've done those 2 examples. If you wanted to do age, you would get 30 as well. And we'll just test that. And now we're going to go over lists. Or actually, we'll go over one more thing. So let's say we wanted to change the value for this key name. We want John to become Abe. So what we would do is my dictionary. So let's print name again. So my dictionary name is equal to Abe. And now at the end here, let's print my dictionary. And you can, with the Python IntelliSense, you can just pick the keys out from here instead of typing it out. And over here, I'm going to print the full dictionary so you can see the contents actually. So we're going to print the dictionary, and then we're going to print the value of the key name. We're going to redefine the value of the key name to Abe. And then we're going to print the dictionary again. And then we're going to print the value of the key name. And this is called key notation. Let's run this. And the output will be the dictionary in its entirety, the value to the key name, the dictionary in its entirety, and then the value to the key name, which we just changed to Abe. Originally it was John, we printed it, we changed it to Abe, we printed the dictionary again, and then we printed the new value to the key name, which is now Abe. Okay, this takes practice. You're not going to get it all at once, right away. You're not going to get it. You need to practice. You need to look at this and not be confused, which again takes time. But now we're going to go over lists, which are way easier. So I'm going to go down a bit so the dictionary doesn't confuse you, but we are going to go back there in a bit because we're going to mix key notation with index notation. So we're going to say my list variable is equal to a list 1, or let's say 7, the string hello, and then let's use a floats 3.1 and a Boolean false. So my list variable, if you highlight over it, it says list. And if you wanted to print the type the same way we did earlier, it would be print type my list variable. Okay, and this would print list. So what is index notation? So what if we wanted to print the second item in the list? And this is going to kind of expand on your understanding of why the for I in range loop. My goodness. Why the for I in range loop starts at 0. Right? That was a question we had before. Let me just comment this out temporarily. So why does it start at 0? And the answer is Python uses 0 indexing by default. So you will always start at 0. If you do not start at 0, then that's something someone created in a modified function. So the function's modified, they don't start at 0. That's fine. But by default, it starts at 0 for many of the native functions that come with Python when you install it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 never prints. But if you count these, there are 10 numbers. 0 indexing means you start from 0. So if I wanted to print the second value here, you would think it would be 2, right? So similar to key notation, we're going to use my list variable square brackets 2. But that would be wrong because we use 0 notation in Python. So technically, this is the 0th index, which is the first one. This is the first index, which is the second one. This is the second index, which is the third one. And this is the third index, which is the fourth one. So if I printed 2, you would expect hello, but you get the 3.1, the floating. See? So this is something you need to have ingrained. If you're not defining otherwise, which you can do, for I in range 1 to 10, or 1 to 11, if you're not defining that otherwise, it will always start at 0. Okay, so I'm defining it to start at 1. That's why it starts at 1. But with native, and when I say native, I just mean defaults, like the way Python was written by default. This is how things work unless you change them. You use 0 index notation. So if I wanted to do for I in range 1, 0 to 4, you'll see here, instead of printing something that I put in manually here, let me just fix this so it's easier to look at. If I wanted to print using I, instead of using this here, I can just put I in here, right? Because I is a number, and in index notation, you need to input a number, okay? Instead of a key in dictionaries, use a number in lists. Okay. So we're going to print this and see what happens. So we're going to use the numbers 0, 1, 2, and 3. And you see here, it prints 0, 7, 1, hello, 2, 3.1, and 3, false. So this is 0, 1, 2, and 3 index. Okay. Let's say I did 5. There is no fifth index. What would happen? You would get an out of range error. List index out of range. There is no fifth index, or excuse me, there is no fourth index. If we did 1 to 3, this would be the numbers 1 and 2. You would get 1 and 2, hello, and 3.1, as we do here. So removing this example with the for loop, actually, I think you have an understanding now. That was pretty much it. So let's combine these two things. So we know how to access dictionaries, dictionary values, dictionary key values in dictionaries using key notation. Now, we also know how to use index notation for lists. So what would happen if I had another key value in here? And just for your, just FYI, if this looks too complicated to you, you can actually hit enter for dictionaries and lists. And it looks way nicer, in my opinion. Let me just fix this up for you. I didn't do it initially, so that's why it looks a little funny. But as you're creating them, you can actually do this. And it looks a bit easier to read. This is an ugly dictionary, so we can say this is a number string. And this is number, another number string. This looks easier to look at, kind of. This is usually not what data will look like, or actually it kind of is. You kind of just got to get used to it, but this is easier to kind of see, in my opinion, and probably yours too one day. So let's just proceed. So let's say I had another key value, and you need a comma before you declare another key value. Let's say this is likes. That's the name of the key. And the value is going to be a list. And let's have strings in here, running, I don't know, surfing, and then comma. We have also, I don't know, conversating. So now we have a dictionary with key values, but one of these keys has a value that's a list. So how would I print the first index or the second value in the list in this dictionary for the likes key? How would I do that? You would combine key notation, and let's print the likes key, with index notation. And you can use single or double quotes. I'll input this here just for an example. You can use single or double quotes. So we'll combine key notation with index notation. So we want the first index, which is the second value in the list of 3 values. So we'll do 1. Okay. Remember, when we have a list, let's call it 7 or 8, 10, 17, just a random list, we always start at 0 because of zero indexing. So you'll see if we print the, and I'll just run this. I feel like I'm repeating myself at this point, which might be annoying to you. Let's run this. And I'm just going to clear So you can get just this part down here. Okay. So you'll see here we print the full dictionary. Then we print the list. Okay. And then we print the index, the first index of the value for the key likes in the dictionary, which is surfing here. Okay. It's kind of a complex concept. And then tuples are pretty easy. And let's actually add one more thing. My dictionary likes 1 is equal to, let's say their likes, one of their likes changed. Now they like skateboarding. And then we're going to print my dictionary again. And you could use key notation and index notation again if you wanted to. But I'm just going to print the whole thing again. And you'll see in the likes, surfing became skateboarding because we changed only the second index, the first index, which is the second value of the key, the value to the key likes in the dictionary to skateboarding from surfing. And tuples. Tuples are immutable. So back here, we were able to change things. We could change the index of a list. We could change the value to a key, as we changed John to Abe and surfing to skateboarding. With tuples, tuples are represented between parentheses, open and shut parentheses. Let's just use 7 and 10 again. And if you highlight over it, it's going to say my tuple variable. Maybe this one would be better. Actually, this is not going to tell you it's a tuple for some reason. It's just an IntelliSense kind of glitch there. That is strange. So I guess a tuple actually has to have at least 2 values, right? That makes sense. So you'll see the first one is actually an int, which is confusing. So I'm not going to show you that example. But so the tuple is at least 2 values within parentheses, and you'll see it's a class tuple here when we print it. A tuple is immutable. Immutable means nothing can be changed. Mutable means something can be changed, e.g. lists and dictionaries, e.g. tuples. You cannot change, if I try to say my tuple variable 0 as if it was a list is equal to 1, and then print my tuple variable, I don't believe it errors. I think it just doesn't change. No, it does error. Tuple object does not support item assignment, so you cannot change the value within a tuple. The reason, why would I use a tuple instead of a list or a dictionary? Or maybe, why would I use a tuple instead of a list? You would use a tuple instead of a list if you have a lot of tuples, because the utility that comes with using lists actually uses more memory. A tuple uses less memory. I actually don't know how to print the memory used. That's something you could probably ask ChatGPT if you wanted to. Like, how do I print how much memory this variable is using? And before I go off top, I'll quickly go off a tangent. Using ChatGPT is not a bad thing. It's not cheating. I think if you're new to developing, you should not use it from the get-go to wherever you're going. You should use it as a resource, not necessarily a learning tool. You could technically ask it to teach you something, but I think it's not refined enough or studied enough to say, yes, studying with ChatGPT is better. Primarily, people use it to cheat. They use it to cut corners. For something like this, where you want to know how do I print the amounts of memory a variable holds, it would give you, hey, like import this function, and imports, I believe, is one of the chapters as well. Import this function and use this method from this function, and now print my tuple variable when you put it into that function, and then you'll get however many kilobytes or bytes that the list is taking up as opposed to the tuple. Where, again, tuple uses less memory because it has less flexibility that a list or dictionary has. These are more complex data structures. They can be changed, they have extra utility, they need more memory. So mutable, rounding back to the beginning, mutable means something can be changed. Immutable means cannot be changed. There are some examples on AlgoLearn of things that cannot be changed as attributes of a class, or maybe not attributes, parameters of a class. When you're creating an object, when you're submitting a transaction, for example, the manager address cannot be changed. The clawback address cannot be changed. The freeze address cannot be changed. Asset names, unit names, what else? URLs. These things cannot be changed. And we'll go over at a later point how you can avoid some of these things. The reserve address can be changed. That's a mutable parameter. So in ARC19s, they kind of use the reserve address to reference metadata on an IPFS by converting the hash into bytes that match AlgoLearn address encoding. And then you have, it's a bit too complex to go over now, but there's ways around immutability. There's ways you can make things still be able to be changed by using alternative methods. So we have to be kind of clever on AlgoLearn because Silvio kind of left us with this, amazing chain, but there are some things we can't really attack too much because he made it this way so it would be as secure as it is currently, as efficient as it is. Anything that improves that is audited very well and tested, and it's not really challenging Silvio's original creation. It's kind of just expanding and kind of making things maybe a little bit faster without sacrificing any of the security. So this is something you'll see a lot with NFTs. And also, I mean, off the top of my head, that's pretty much it. But in general, tuples are not very popular, but the concept of mutability and immutability is very popular in blockchain if you're a developer. You will come across it many times. So I'm gonna, I'm gonna close this chapter for dictionaries, lists, and tuples. But variables is pretty much done. If you have any questions, reach out to me. You can go to YouTube, check out other videos. You can read documentation online if you want more information, or you can ask ChatGPT if you'd like. I just wanted to give a quick, kind of foundational instruction for these things, but I do want to dive into Algorand blockchain and more cooler things aside from just the standard information, which I hope you did retain here, and I hope I was helpful. So we're going to cut it here. Thanks for watching, and good luck on the next chapter.